Hello. In this video, I'm going to show you how I implemented Milestone 1 of the original Minesweeper in React. So if you don't know what Milestone 1 is, please check out the video that I'll have linked in the description where I explain what Milestone 1 entails. Basically, it's just this button and this board, but there's a little bit more to it, so check out that video so that you're informed about what exactly Milestone 1 entails. And I'll show you how I implemented it. What's important to me is to write clean code, sound code. And when I do that, I usually do my best, and then I find like clunky places in the code, and then I try and fix them. So this is how the code looks after I fixed everything that I thought was clunky in the code. So the root component is app, and it renders the game. And the game component renders the SmileyButton and the board, which are clearly this thing and then this thing. And before we look into the SmileyButton and the board itself, let's talk about the heart and soul of this project, which is the game service, which is the model for the game, right? So I first modeled it a certain way, then I found that it was clunky, it wasn't working, and I modeled it this way, and I'm really happy with this model. I think it's really good. So let me show you how it looks. So the game model is stored in this variable, and the game model has 5 properties: status, solution, cell states, danger chords, and exploded bomb chords. Let me explain what each one is because it's very important. So status is where are we at in the game? Idle means the game is in progress, you haven't won yet, you haven't lost yet, and you haven't clicked the mouse down. So this is just the idle game. This is also an idle game, nothing is happening. This is not an idle game because you're in danger mode. If you'll watch my first video about Milestone 1, you'll understand what I mean by danger mode. And then this is back to idle, right? So that's idle status of the game. Danger is there was a mouse down on one of the cells of the board, and there was no mouse up yet. Lost is when you stepped on a bomb, right? So the game is over, you lost. This is the lost state. And won is the game over, but you've won, right? You've exposed all the non-bomb cells. I haven't yet implemented one, but it's pretty simple to do, so we'll get to that in Milestone 2, but you know, it's not a big deal to implement that. Okay, so that's status. So the game obviously starts off with status of idle, right? And so what is solution? Solution is how the cells of the board look underneath. So right now, you can't see the solution, but it is there underneath all the cells, right? This is an empty cell. This is a cell with a 1 in it. This is a cell with a 2 in it. This is a cell with a bomb in it, right? So the solution tells you what the board is underneath. So for now, the solution is hard-coded, which I think is a good idea at this point, because later on we can generate it randomly. That should be pretty easy to do, but for Milestone 1, it makes it so much easier for this solution to be hard-coded because I know where the bombs are, so it helps me test, test my code. So basically, I put a bomb up here and 2 bombs down here, and then the numbers are, hard-coded according to the location of the bombs. And then there are some cells with 0, which means that 0 means like empty cell, 1 means a cell with a 1, BB means a bomb. All right, so basically the only things that can appear in the solution is anything between 00 to 08 and a BB. That's it. Those are the only possible things to put in the solution. Okay, so that was the solution. What is the cell state? Cell states is like an overlay on top of the solution, and it means what is the state of each cell. So un means unexposed and unmarked. So that's basically what this is. It's an unexposed cell. It's like a raised button. And FL is an unexposed cell that's marked with a flag. So this is a flagged cell. Q means it's unexposed and marked with a question mark. I haven't implemented that yet, so let's forget about this option. And X means exposed, right? So this is exposed, this is exposed, this is exposed. So basically what you see on the board is a combination of the solution and the cell state. So if the solution is 0, 1 and the cell state is exposed, then you will see 0, 1. If the solution is 0, 1 but the cell state is unexposed, you will see a raised button, right? And the service also gives that kind of processing, which I'll talk about in a bit, getGameCell, which tries to determine how the cell should look given that this is the game state. So we'll get to that in a bit. So we talked about the solution, we talked about the cell state. So cell states is like this overlay on top of the solution. And what is DangerCoords? DangerCoords is the coordinates of the danger cell, meaning we're in danger mode, mouse down was clicked, and the mouse is currently hovering over the cell, and there is no mouse up yet. So let's explain what that means. So if I click here, the DangerCoords is this cell, and if I move my mouse without doing a mouse up, this is the cell with the DangerCoords, and so on. And if I go outside the board, the DangerCoords is null, but we're still in danger mode. You can see the smiley is scared, because if I hover back on the board, I'm still doing this danger mode behavior. And once I do a mouse up, that's it. DangerCoords is null, or should be null. And exploded bomb chords is very simple. It's when the status of the game is lost. And this is the bomb that you stepped on that resulted in the game being lost. So why is that important? Because that bomb is displayed with a red background. So you have to know which bomb you stepped on that caused you to lose the game. So this is pretty simple. So the first four are basically what model the game. They're the heart and soul. And they make everything so much easier, you'll see in the code. Okay, so what else do we have in the service? We have getGame, which gives you the game, which looks something like this. But the components, the React components, do not try and interpret, okay, so what should I display? No. Like I said, the game service helps the components figure that out so that the components are as clean as possible. Okay, reset game status just resets the game to idle status. Sorry, it doesn't reset the game. It resets the status of the game to idle. So basically, if I lift the mouse here, it reset the game to idle. exposeCell. exposeCell is that recursive behavior, right? So if I do a mouse up here, it exposes this cell and it exposes all the cells around it recursively until it no longer exposed any non-number cells, right? So the way exposeCell is implemented is, let's get the state of the cell from the game. If it's a flagged state or it's an exposed cell, then we're done, right? Because if I expose a flagged cell, basically I do a mouse up on a flagged cell, nothing happens. It doesn't expose the flagged cell. That is by design. And also if I do a mouse up here, it doesn't expose anything because it's already exposed. So we've handled those options. Actually, I could have just maybe done reset game status here. That would be a bit prettier. Okay, so basically what happens is when you expose this cell, you just reset the game status. You're back. You're out of danger mode. You're back to idle mode. And that's it. Okay. Now, what else can happen when you expose a cell? If the cell solution is a bomb, then you just lost the game, right? So we break the pointer of the game and we basically create a new object which is identical to the previous game, but the status is lost and the exploded bomb coordinates are the coordinates of the cell. So what that means is if I expose this cell, the game becomes lost, and this is the exploded bomb coordinates. Very straightforward. Okay, so these are the cases where we're done, but if we're not done, if we expose this cell or this cell, we need to do some more work. So what we do is recursively expose the cell and its neighbors as needed. So we create a deep copy of the game, and then we recursively expose the cell at this row and this column index. And at this point, after we'll go into this in a second, but after exposing the cell and all of its neighboring cells as needed, here's when I would check for a win. And I haven't done that yet. So what happens is the game status returns to idle, and then we break the pointer of the game and update it with a new game. So let's see what exposeCell does. So this is a private function. That's why it starts with underscore. Okay, so first of all, we literally expose the cell. We change the cell state of that cell to X, to exposed. And now, if we just expose the cell that is not 0, 0, so what is 0, 0? It's like this guy. If we exposed a 1 or a 2 or a 3 or an 8, right? And it's not a bomb either, because we've already handled the case of a bomb, right? Remember? Okay, so if it's not 0, 0, we're done with the exposing. Otherwise, we need to perhaps recurse. So what do? We iterate around all of the surrounding cells. So from -1 to 1 in the row and from -1 to 1 in the column. And we check, are we on the center cell? So that's not interesting. We continue. Are we outside the bounds of the board? That's not interesting. So we continue. Or if the cell state is unexposed, is not unexposed, we continue. So that means if it's flagged or if it's exposed, we do not need to expose it, right? We only need to expose the exposed cells. And perhaps the question mark, I'm not sure yet. So if this is not the case, we recursively expose the cell. So that's what causes this behavior, where it exposes this cell, and then it exposes this one, this one, this one, and then here it exposes this one, this one, this one, right? So that is my recursive implementation of exposeCell. You might have a different one, I don't know, but I'm pretty happy with it. So that is exposeCell, another heart and soul of the game. getGameCell is also another heart and soul of the game. So basically, the React component that renders each cell asks the game service, what does this cell look like? So it says, this is the row and column index. And how do we figure out what that cell should be rendered as? So cell state is the state of the cell, and cell solution is the solution of the cell. So you might remember that the solution is this, and the state is the overlay on top of it, right? So if the game is lost, then the cells should be, the way that the cell is rendered is different. Because when the game is lost, all the bombs are exposed, even if we didn't expose them, if we didn't click on them, right? The bomb that was stepped on, which caused the loss, is red. Let me just show you that. Okay, so let's flag, and then let's step on a bomb. So you see that when I lost, this bomb was exposed. That's because I lost. And this bomb looks like it has a red X on it because I incorrectly flagged this cell. And this looks like a flag because I correctly flagged this cell. So that's what happens when you lose. So if the status is lost, then if the solution is a bomb, then if this is the exploded bomb, the bomb that was stepped on, it should have a red background, and that is represented as a BR, or bomb red, which is the name of the SVG that contains this image. If the cell is a flag, and it is a bomb cell, right? So it was correctly flagged, it stays displayed as a flag. And otherwise, just expose the bomb. So for example, this one should just be exposed, displayed as an exposed bomb. And if, right, so everything here has a return. So we now know, at this point of the code, we know that the cell solution is not a bomb. So if the cell is flagged, and it's not a bomb, right? Because if it were a bomb, we'd go into here. Then we return BX, which represents a bomb with a red X on it, right? Okay. Now, if the cell is exposed, then we just return the cell solution. So what is important here is that we know that the status is not lost. Because we don't know that, because we might have not returned here. So it doesn't, that's not true what I just said. Anyway, so there's a bit of a delicate flow here where you return in all these cases, but you don't return in this case. So you have to be very careful with this code. So if the cell is exposed, just return the solution. And if this is a danger cell, it should be displayed. It should be displayed as a 0, 0 if it's unexposed. So basically, if it's a danger cell, it has to look like it's like this unexposed sort of thing. So this is a bit of the delicate code, which is maybe hard to read, but like you need to implement this function, and I'll show you where it's used. So isGameOver just checks whether the status is lost or won, and the importance of that is that, the React component causes nothing to be clickable, and right click doesn't work either. And also like the smiley becomes like this, and markCell handles basically the case where you right click a cell. So it basically toggles flag and unflag. So, let's say I'm clicking here and I right click here. It doesn't flag it, right? It only flags this kind of cell. So it checks the current cell state, and it wants to set the new cell state. So if the current cell state is unflagged, the new state is flagged, and vice versa, right? And if new cell state wasn't set, so that means that current cell state wasn't unflagged and wasn't flagged, then don't do anything, right? That's like right clicking here, it doesn't do anything. Otherwise, just structured clone for the cell states and update the cell states to be the new cell state and break the pointer for the game. So that's how this works, right clicking and flagging. setDangerCoords is basically what the components will use in order to say that the mouse down is hovering on this cell or not, right? So what it does is it sets the status to danger, and it sets the danger chords accordingly. And I should probably in reset game status to idle, I should probably set the danger chords to null. Yeah, let's do that. Danger chords null. Should have done that, but did not. Okay. It works regardless, but it's a bit dirty not to do it, I think. Anyway, so that is the game service, the heart and soul of the game. So now let's get into the components, which are a lot cleaner. There's not a lot more to cover. Okay, so the game basically, like I said, renders the smiley and the board. So let's see how the smiley is implemented. And when the smiley is clicked, it resets the game, right? So if I click here and I click on the smiley, it resets the game. If I click here, but I click here and then do the mouse up here, it doesn't reset the game, right? The mouse up needs to be here in order to reset the game. So the way that's implemented is very simple. The SmileyButton just renders a button, and it uses some classes which basically cause the correct SVG to be displayed according to the status of the game. So if the game status is lost, remember from the service, then it should render the sad smiley like this. And if we're in danger mode, it should render the scared smiley like this. And if we are in idle mode, it should render the happy smiley. And how do we render the pressed smiley? The CSS renders the pressed smiley, so we'll get into that right now. So the CSS or the SCSS looks like this. If the smiley button by default has the unpressed smiley, right? This one. And it uses a background, okay? So if the button also has a smiley scared class, then it'll show the scared smiley. If it also has a smiley sad class, it'll show the sad smiley. And if the button is active, meaning there was a mouse down, and it's hovered over, the background image is smiley happy pressed, right? So if this is active and hover, this is active and not hover, this is active and hover, right? And this is a mouse up. So my cat is talking to me. So that's how the smiley button is implemented. As you can see, pretty clean. I didn't have to manually do any of this stuff. The button does that for me, and the CSS helped me out with that as well. Okay, so that's the smiley button. Now let's get into the board. Okay, so what does the board do? The board gets the game, and it reports, was there a left mouse down on a cell? Is there a mouse over on a cell? Is there a mouse up on a cell? Is it a right down on a cell? Or did the mouse go outside the board? So before we look at this, let's look at what happens on each of these events. So on left mouse down on this cell, if game is over, don't do anything, right? So if the game is over and I click here, don't do anything, okay? Otherwise, set the danger coordinates to be this cell. And load game, that basically just updates the state, right? Set game to be the game from the game service, just the state, the React state. So basically on left mouse down, if we're not in game over, this is what happens. It sets the danger coordinates. And the left mouse down is reported on each and every cell. So we'll see how that goes. On mouse over, if we are not in danger mode, then it doesn't matter that there's a mouse over. But if we are in danger mode, it does matter that there is a mouse over, right? And in that case, we just set the danger coords to be the new cell, right? So, so that's what happens here. So you can see that the model is modeling how the game should look, right? The component doesn't know that it's going to look like this. That's what the game service is for. I think it's very well written. You tell me what you think. Okay. And every time we do something through the game service, we load the game, which basically updates the state, the reactive state. On mouse up, right? So there was a mouse up here, okay? Then we stop propagation because we don't want the mouse up to reach down to the document. I'll show you why in a bit. If game status is not danger, we return, because who cares that there was like a mouse up over here. Wait, that's not true. I don't know if I needed this, but let's leave it alone for now. So we expose the cell. Remember that complex logic. It's all in the game service, not in the components. And then we reload the game. And then we re-render the game according to the model, which shows us. So at any point, we can just print the model and see what the model looks like. And that is how the board should be rendered. There's no complex logic in the components themselves. Although this code did take a bit of time to write correctly. On right mouse down, if game over, do nothing. Otherwise, mark the cell, which, as you may remember, toggles the flag on this cell or not. Oh, and by the way, if you wanted to implement replay of the game with back and forward, blah, 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 you would need to have a proper model that models everything. And that's why I'm really happy with the way I implemented it. Okay, on board mouse out, what that means is if we are in danger mode, we want to set the danger coordinates to null. Otherwise, the danger coordinates would be sticky on the last cell. So on board mouse out, we want to set the danger coords to null so that none of the cells appear pressed. And that's it. That is game. Okay, so now let's talk about the board. So the board has to report all of these things correctly. Let me see if I missed something in game. Yeah, I missed this. The event listener for mouse up. I added a mouse up event listener for the body. Why? Because if the game is not over, we need to reset the game status. So that's what handles this case. Click, right, the mouse up here. The mouse up here is what resets the game from danger back to idle, and then he's happy again. And then when I hover here, it no longer appears pressed. Okay, so that's reset game status. Sorry, that's this event listener mouse up. And obviously you need to use callback, otherwise remove event listener doesn't work because the function is different when the component is re-rendered. Use callback causes this function to stay the same pointer to a function. Okay. So let's look at board, right? How is the board implemented? So the board basically gets the game and it looks at the solution of the game and it maps that solution per row and then per cell. And it renders a cell accordingly. So it gives the cell component the information about what is the row index and column index of this cell. And the cell will notify when there was a left mouse down, when there was a right mouse down, when there was a mouse over, and when there was a mouse up. So that will be a lot easier to implement on an individual cell, and the handling of that happens in the game, as you saw, because the game holds the state, the game component, right? The game component holds the state. All right, so that's the board. And then let's look at the cell. The individual cell is just a button with an image inside of it. And the on mouse down, on mouse over, on mouse up, and on context menu is what happens when you right click. It's this. So what you needed to do was when you right click for the context menu not to appear, so all it does is prevent default, right? Prevents the context menu from appearing. On mouse down can be either a right mouse click or a left mouse click. So on mouse down checks, is it a left mouse button down or a right mouse button down? And then it just reports that up to the parent component, to the board, which then reports it up to the game, right? On mouse over and on mouse up are directly reported from the button itself. And the image draggable false is just needed in order to, when we are supposedly dragging, we don't want the cell to be dragged. And get image is again, look at how small this code is. It asks the game service, how should this game be displayed? How should it be displayed? What should it look like? Well, that depends on the status of the game. That depends on the solution of the cell. That depends on the state of the cell, right? It depends on the danger chords. So because the model is so all-inclusive, then the cell just has to ask, how should I display it? Remember, we looked at this implementation. Not going to go through it again, but basically the service does all of that for the cell. So as you can see, the components are very clean, and they only handle things that have to do with the DOM, whereas the logic, heart and soul of the game is in the game service, right? So I think I'm pretty much done. I will explain that I have like the cells here, the SVGs for the cells here, and the SVGs for the smileys here. And then when you get the image, let's say the cell, where's the cell? When the cell gets the image here, it only has to concatenate the correct path to the image, and there it is. So that is my solution. There was a tiny bit of work in CSS, so the game is just display, flex, and blah, 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 because, just to have the smiley on top of the board. We could implement that differently. It doesn't really matter. and the board, each row is display flex to have the cells of the row in a line. And then the cell has user select none, and so that it can't be highlighted, right? Can't be highlighted. And the height of the cell, for now, what I did was I hard-coded these variables. The original cell size and the original smiley size, which is the exact size of each of the SVGs that I painstakingly created myself. And then I have this scale variable, which basically scales the whole thing up. So see how big it is, right? This is how big it is. And if I do a scale of 1, it looks like this. If I do a scale of 5, it looks like this. Okay, so the reason I did this was because I had some glitches where like a tiny sliver of white was showing underneath, and this fixed it. And that way I have complete control of how large the board looks by default, and people can zoom in, zoom out like this. But I have complete control over this, and I could also make this like somehow controllable by the user, but for now it's hard-coded as, I think, what was it? Was it 1.5? I can't remember. Can't remember what it was. I guess it was 2. Yeah. So that is, I think, it. What do you think? Did I cover everything? Oh, the cell itself, I cleared button styling, which is just a mix-in that, clears any default styling for a button because the cell is a button. And the height of the cell is, again, the original cell size times the scale. Anyway, there was a little bit of fidgeting because the cell is a button with an image in it, whereas the smiley button is a button with a background. Okay, so you had to do background size and all this stuff. But those are things that are easier done when you're coding and not just like, why did I do it this way? I don't know, because I did it a certain way and it wasn't working, so I wrote something that worked plus something that looks elegant as I can. So basically this code, I hope it was insightful, helpful in some way. I'd love to hear how you implemented your Milestone 1, and let me know if like anything that you saw here gave you some kind of inspiration to change your implementation, or if you think there's something in my implementation that could be done better. I will leave a link to the branch point of my implementation of Milestone 1. And if there's anything else you need, just write me a comment. And if you enjoyed this video, write me a comment. If you have any comments, write me a comment. I'd love to hear them. I'm sure this was extremely long. Let's see how long. Oh, just 33 minutes. That's all. Not so bad. Not so bad. So I'm going to implement Milestone 2, which I need to figure out what I want to include in Milestone 2. So it might be something like the styling of the thing. Like no additional logic, just the styling. Just let's look at Minesweeper X again. So, obviously this is not how the board should look. It should have like all these borders and stuff. But remember, it's not generated with any diagonals. I have to manually create. Let me show you. I have to manually create this SVG and this SVG, because you can't just do the diagonals. There are no diagonals. See, there's no diagonal. And I think that's beautiful. I do. So basically, I'm going to painstakingly create these SVGs, and you can just take them, right? And I need to do the SVGs for each digit and the SVG for this little thing and everything. Like, it's going to be beautiful. It's going to be fun. So basically, maybe next milestone will just be a style milestone. Another option is to implement like the randomization of the board, or some kind of menu which lets you choose the like in Minesweeper X, you can choose Do I want the beginner game? Do I want the intermediate game? Do I want the expert game? Or do I want a custom game? So that shouldn't be too hard, but it is a bit of work. We also need to implement the question marks. I do not think that is for Milestone 2. And we also have to implement the model for these guys. So basically what they do is, first of all, this guy is a counter. So once you started the game, it just counts the seconds. And this guy counts how many bombs are left. So when you flag something, it tells you, okay, there are less bombs, right? So let's see the beginner game. Like if you keep flagging, you can get to negative numbers, if I'm not mistaken. Yeah, you can get to negative numbers. So all of this needs to be implemented. And there's probably more that can be implemented, which I can't think of off the top of my head, but those are pretty much what you need. And also the thing with the solution, like noticing that the game is solved and then he has sunglasses when you solve the game. So yeah, that is my plan. I will post a video for Milestone 2 once it's ready. I know nobody is watching this video, but maybe in future someone will watch it and enjoy it. So I'll stop here for now.